All right, today we're going to look at sections 8.2 and 8.3, which are looking at the different ways that we are going to talk about proving triangles similar. We are not going to actually write out proofs, but we're going to look at the ways that we could justify or prove that triangles are similar to each other. There are three methods that we are going to look at. The first one is angle of similarity. So if we have two different triangles and we have one pair of angles that are congruent and another pair of angles that are congruent. So angle is going to be two pairs of corresponding angles congruent. Another method would be side, side, side. And this is when we're going to have three pairs of corresponding sides that are proportional, which means they are going to have equal ratios. So if I have two separate triangles here, let's say we go with a 5, 6, and 7. If it was dilated by 2, that would mean all sides would have to be multiplied by 2. So we would have, say, 10, 12, and 14. So they are all three pairs of corresponding sides proportional. And then the third one is a combination of those two, where you have two pairs of corresponding sides proportional, and the included angles congruent. So you might have, say, 5 and 6 for these two sides, and then it would be 10 and 12 if it was dilated. It could be multiplied by anything, but then you would also have the pair of angles in between them. So we need to remember these three methods to justify that triangles are similar to one another. So in this first diagram, looking at the fact that I have parallel lines, could I prove that these two triangles are similar? And there's going to be a few different ways that you would be able to justify this. Number one, you would have vertical angles are always going to be equal to each other. And then because of the parallel lines along the transversal, we would have alternate interior angles. So we could say that these triangles are similar by angle of similarity. In this next pair of triangles, are these two triangles similar to each other? We would have to justify this. So when we look at this, take the corresponding sides. So start with AB and DE. So 8 over 2. And then do another pair of sides, BC and EF, which are sides 12 and 3. And then the last two sides, which would be 10 and 2.5. And so are all three of these ratios similar? They all reduce to 4 over 1. And so because all three of these sides have equal ratios, or they are proportional, then they would be similar by side, side, side. Now, looking at these three triangles, it says are either one of PQR or STU. So are either one of these two similar to the last one? So let's do this first one here. Compare the corresponding sides. So we have to do the smallest side of each. So is 20 over 8. And there's another 20 over 8, so we don't need to do that one. Does 20 over 8 equal 30 over 12? And when I reduce those, they are both equal to 5 over 2? So that answer would be yes. What about the other one? Does 12 over 8, comparing 12 and 8, and then 16 over 12. And when I divide the first one by 4, I get 3 over 2. When I divide this one by 4, I get 4 over 3. And so the answer for those two is no, because they don't equal each other. So in this case, triangle STU is similar to triangle VWX. So number 4, are these triangles similar? Compare corresponding sides. So look at the smallest sides, 3 and 9. Does 3 over 9 equal? Compare the next pair of sides, so the middle sides, which will be 4 and 12. And then compare the last sides, which are 5 and 15. And all three of these do reduce to 1/3, so they are all three equal to each other. So since I have all three sides, they are similar by side, side, side. Are these two pairs of triangles similar? Well, I need to find the missing angle here, and when I subtract 119 and 41, I get 20 for this last angle. And when I subtract 119 and 51, I get 10 for this angle. I have no side lengths, so side, 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 and side, angle, side are not possible to justify the triangle similar. So I would have to look at angle, angle. I do not have two pairs of angles congruent. I only have one pair of angles congruent. So therefore, I cannot prove they are similar. They are not similar to each other. Looking at these two triangles. First off, I need to know that I can take vertical angles are congruent. So I can take these angles here in the middle and say they are congruent to each other. And then compare the smallest side of one and the small side of the other. So does 2 over 4 equal the next pair of sides, 4 over 8, which does reduce to 1/2. So they are both equal to 1/2 with the angle in the middle. Therefore, side, angle, side does prove that these two triangles are similar. Determine if these two triangles are similar to each other. If so, tell why and write the similarity statement. So for this one, we're looking at the top triangle and then the whole triangle. So when I look at corresponding sides, the top first of all, they do share an angle. Angle J is in both triangles. So the side on the left for the green one is 2, and then the side on the yellow one is the whole side, which is 6. When I compare on the other side, I go 3 and 9. So the similarity ratio does reduce to 1/3. Yes, they are similar, and I have two sides and the angle in between, so it's side, angle, side. And then when I similarity statement is talking about which triangle. So in this case, it's triangle JKL, and then say them in the correct order here. It would be J, M, and N. For number 8, in one triangle, compare 4 to the smallest one, 6. So it does 4 over 6. I have another 4 and another 6. But then I also have this side 6 that is in the yellow one and the blue one, so I need to do 6 over 9. And all of these do reduce to 2/3, so my similarity ratio is 2/3. They are similar by side, side, side. And my similarity statement would be triangle PQR is similar to a triangle PRS. Go ahead and do 9 and 10, and then you'll enter those answers. So pause the video and solve 9 and 10. Same thing here. Pause the video and solve numbers 11 and 12. Verify that they are similar to each other. Remember, take the smallest side of one to the smallest side of the other. For number 13, we're looking at the scale factor between these two triangles. So first look at this triangle. I can see that this distance is 1 and this distance is 2. And then when I look at the entire triangle, this distance is 2. So when I compare the red triangle to the blue triangle, there's a ratio of 1 to 2 on the bottom. On the left side, it is going to be in a ratio of 2 and I don't know, so x. I would cross multiply this to solve. And I get that x is 4. So my distance from 0, 0 up to h needs to be 4, which would make my h coordinate 0, 4, because my scale factor is equal to 2. I am doubling the size of the triangle. Go ahead and pause the video and solve for 14 as well. Then lastly, for number 15, are the following triangles similar to each other? We do have a pair of angles in the middle, so then when we compare our corresponding sides, it's 15 over 9 is equal to 10 over 6. Is that equal? And it does reduce to 5/3. So 5/3 is my ratio. So they are similar by side, angle, side. And then in order to find SM, I need to make that x. So 5 over 3 is equal to x over its corresponding side of 12. And then I can cross multiply and get 60 equals 3x, which means x is 20. So SM is equal to 20. Make sure you've completed the other problems throughout here, and then we will check those answers.